Hello and welcome to the Chemistry Practical Podcast.
We're here to explain in as much detail as possible about the most relevant chemistry practicals you'll have to do as a 1 year here at the University of Leicester. And remember, the podcast is meant to be used alongside your practical manuals.
This time we will be covering Experiment 105, which is the standardization of a potassium permanganate solution, also known as a titration. Do not handle any chemicals above your head, as you may spill chemicals into your eyes. For this experiment, there are two main chemicals to look out for, which could possibly damage your eyes. One of them is sodium oxalate, which is poisonous, so it's fatal if swallowed. Do avoid breathing any dust and avoid any contact with skin or eyes. It is also corrosive, so keep that in mind, and make sure to dispose of small quantities with large amounts of water.
The other is potassium permanganate. Harmful if swallowed, in large quantities it's very toxic to aquatic life. Spilling on yourself can and will cause burns, and again, dispose of small quantities, less than 10 grams, with copious amounts of water. Side note, potassium permanganate is a very strong oxidizing agent, so when cleaning any equipment, in particular the burette, do not use acetone.
Commonly used in redox reactions, the deep purple colour acts as a very convenient internal endpoint indicator. Note that the potassium permanganate is not particularly stable and you would do well to re-standardize the solution before use. At room temperature, permanganate redox reactions are incredibly slow, therefore the endpoint is almost often determined between the ranges of 60 to 80 degrees Celsius. Now, before you start the practical, you will need to obtain a concentrated solution of potassium permanganate from your demonstrator and label it with your name. Next, dilute the solution with 500 ml of deionized water to give an estimate 0.02 mole solution. In addition, use a top pan balance to transfer approximately 0.4 grams of dried sodium oxalate into a capped weighing bottle. This will be enough for 2 titrations.
Note: the balances used in the practical are very expensive and are unquestionably delicate, so don't lean on the bench, do not add chemicals to glassware while on the pan, you'll be marked down for doing so. Do not move the balances, don't wear gloves when using them, and for the best results, use the same balance.
Now on to the method. Weigh and record the weight of the bottle, cap and oxalate via an analytical balance to the nearest 0.1 milligram. Carefully tip half of the sodium oxalate into a 250 milliliter conical flask through a glass funnel and reweigh the bottle and cap. Afterwards, tip the remaining sodium oxalate into a second flask. And lastly, weigh out the now empty bottle with the cap and any leftover oxalate dust. Make sure to record all weights directly into your duplicate notebook. Side note, it might also be very useful to grind the sodium oxalate you've collected to remove any large chunks, as it would help when transferring approximately half of the oxalate into the flask.
Add 20 milliliters of deionized water to the sodium oxalate, diligently washing all traces of solid from the glass funnel. Then add 50 milliliters of dilute sulfuric acid. Next, heat the flask via a hot plate till there's condensation appearing around the neck of the flask. Make sure all solid has been dissolved. When moving the heated oxalate solution, put it into a heat-proof mat and not the wooden bench. And do remember to use tongs to handle the heated conical flasks. Now, before moving on to performing the titration, we need to cover how to best make use of the burette. Make sure the tap moves, clamp it vertically with at least 2 well-spaced clamps. When filling the burette with the permanganate solution, lower the retort stand and burette onto a stool. Remember to wear gloves and use a glass funnel. Also ensure that the volume below the taps is full of permanganate before taking any readings to ensure no air bubbles. And remember, when you're ready for the titration, do not leave the funnels in the burette.
Moving on to the titration itself, at first you can use the permanganate rapidly but do swirl the flask actively. Though, as it takes longer for the colour to clear, you will need to reduce the flow of permanganate to a few drops at a time. I would advise rinsing down any unreacted reagents from the flask walls and then continuing until there's a faint permanent pink tinge in the solution. If you end up reaching the endpoint too quickly, when added only a few milliliters of solution, reheat if necessary. And use a white towel underneath the conical flask to assist in detection of colour change. Now redo the titration again until you've done and recorded at least 6 titration. Be sure to weigh out fresh sodium oxalate.
Afterwards, make sure you have recorded all the waves for the weighing bottle when empty with oxalate and after adding oxalate to the flasks, and all of your titration readings before and after volumes in your duplicate book. Lastly, keep any remaining permanganate solution in your group box with a clear label of who it belongs to as you'll be needing it again for experiment 109.
Moving on to the proforma. You will need to calculate the molarity of each titration, then work out the average molarity and the standard deviation. Do consider what to do with any outlying readings. You will also have to write a balanced equation for the reaction and comment on your results, as well as in particular your standard deviation and what this means about your average molarity. A helpful hint when writing your comments is always to use third person.
And that's it. Thank you for listening to the Chemistry Practical podcast. We hope this has been useful, and please review and rate this podcast. Good luck!